So we have 2 times 5x minus 1 times 2x plus 1 is equal to 0. Now the zero product property, yeah, that thing, will still say that, hey, the 5x minus 1 is a possibility of equaling 0. Or the 2x plus 1 is a possibility of equaling 0. Now, the thing that students oftentimes get confused about is what the heck do we do with the 2? Now, is it a possibility that 2 could equal 0? Now think about that for a moment. Can 2 equal 0? No. 2 is like 1 plus 1 or 3 minus 1. It's not equal to 0 though. So this is kind of like not true, so you don't give us an actual solution here. But the 5x minus 1 does. Divide by 5. X is 1/5. Or negative 1/2. So I would actually write this down on the notes. Is x equals 2 a solution? And your answer is no. It's not. These are your two potential solutions. X equals 2 is not a solution. Okay. Now number 4 is going to test our abilities on this one just a little bit, so please be patient with this explanation. As you can see, the whiteboard is a little worse for wear. I've been doing a lot of videos today, so it's getting a little muggy. Muggy, not muggy, muddy. I don't know. It's whatever. Okay. This is a little bit intimidating right now. But just remember, you got 0 by itself? Great. Is it in standard form? It sure is. Can you take out a GCF? X cubed, x squared, x. Sure can. So that's going to be our first move. Our first move is, if I can take a GCF out, I'm going to do it right away. So you can take an x out, but you can also check out 6, 51, and 63. Maybe it doesn't jump out at you, but they all divide 3. So the leftovers would be 6 divided by 3 is 2, x squared. 51 divided by 3 is 17. X squared over x is x. It's 17x. And then 63 divided by 3 is 21. And then the x's cancel. Wow, I'm glad we took out that 3x because these numbers are not nearly as intimidating as, that. So students will oftentimes neglect the first step of the GCF, and it's like you're shooting yourself in the foot when you do that. Look for the GCFs right away. So now we go AC method on just the things inside. So what would multiply to give us 42? That adds up to give us 17. And you can think your way through the list, but it ends up being 14 times 3. Yeah? So I'm just trying to speed it up a little bit, the process here. I guess it doesn't matter who I group with whom. I'm going to put the, I'm going to put the 3 with the 21. 14x with the 2x squared. So 2x squared plus 14x plus 3x plus 21. Hopefully this is becoming a routine step for you, and I don't have to explain it so in depth. Remember, I'm eyeballing these two terms, and I'm saying 2x is what should come out. And then to get these terms inside here, I take 2x squared divided by 2x and 14x divided by 2x to get these parts. They both divide a 3, which also leaves us with x plus 7. So you got 2x plus 3 times x plus 7 and the 3x that we took out at the very beginning. So I'm going to write this over here. This whole thing equaled 0, yeah? So 2x plus 3 times x plus 7 times 3x. Is that still showing up? Yeah, it is. That equals 0. That is technically the factored polynomial, the whole thing. So here's the deal. When can 3x equal 0? Now, on the last example I said, when can 2 equal 0? And there was no x by which to compare anything. So it's kind of like I can't do anything with this except there's an x right there. What happens if there's an x? I can divide by 3. X equals 0 is a solution. All right. It's because of the x that you factored out. That's why x equals 0 is a legitimate solution. Now, you do the same thing with these others. Nothing changes with these. 2x plus 3 could be 0, or x plus 7 could be 0. So then you'd subtract 3, divide by 2. So x could be 0 from the 3x, or x could be negative 1.5 from the 2x plus 3, or x could be negative 7 from the x plus 7. So those three solutions come out. So number 3 and 4 really had an interesting comparison between you take out a 3x, you get x equals 0 as a solution. You take out a 2, you don't get an extra solution out of that. All right, I've got one last example for you. No, 2 examples. And I think my battery's dying, so I'm going to plug that in. All right. All is well. So those were the big hitters, using AC method factoring to basically turn a 3-term polynomial into a 4-term polynomial, factor by grouping, and then pay attention to all the little details of, when can something equal 0 and when can it not equal 0. Now, what happens if there's only 2 terms? Well, let's just roll through the steps like we normally would. Is 0 by itself? Yep. Is it in standard form? Yep. Can we factor out a GCF? Yes. They both have an x. So you take the x out. 7x squared divided by x, 7x. Negative 16x divided by x, negative 16. And it does equal 0. Now, sometimes students are still just kind of scratching their heads with this situation. Like, well, what am I supposed to do? And it's kind of like this. You see the 0 product property? Yeah, it works for this too. I'm multiplying x times 7x minus 16 and saying that yields 0. That means that x must be 0, or 7x minus 16 equals 0. And I don't have to go through the whole rigmarole of factoring with the AC method, because I can solve this equation without doing any factoring. I add 16, and then I divide by 7. 7 goes into 16 twice, with 2 leftovers, and we're done. X equals 0 or x equals 2 and 2/7. No AC method, no AC method factoring was needed, so all I had to do was take out the GCF. So if there's two terms like that, make sure you are, taking a step back and asking yourself, do I need to do this AC method business? All right, let's check out number 6. Although I don't think we need to. Yeah, better be safe than sorry. So 8x squared equals 5x. Again, we're left with a 2-term polynomial. I'll tell you what students like to try right away is they're like, you know what? That whole getting 0 by itself, I'm not going to do that right now. I'm just going to divide both sides by x. And they get the wrong answer every time because they just canceled out one of the solutions. I would advise you guys to keep consistent. Keep a consistency in saying, I'm going to get 0 by itself so I can use the 0 product property and things will not be so confusing. So I'm going to subtract the 5x to get 0 by itself. 8x squared minus 5x is on the left. You can compare it to 0 now. You ask yourself, is there a GCF that I can take out? X. You're left with 8x minus 5. Now, I should be able to just set both parts equal to 0. X equals 0 is one of my solutions, or 8x minus 5 equals 0 is the other solution. Add 5. Divide by 8. X equals 5/8. And you're done. All right, I'm hoping these videos are super helpful for you guys. Factoring trinomials and then solving equations using that kind of same concept is really fundamental for future math classes. So I can't underscore that enough. So it's why I've been spending so much time on factoring with remote learning. And yeah, email me with any questions you guys may have. Make sure you're showing your work. If not, I will just send it right back to you without any credit. So let's just eliminate that middle step. See ya.